So in this question, we are told that the speed of light in vacuum can be taken as that, and we're given the refractive index of a material is the ratio of the speed of light c to the speed of light in the material. We're told that in part A that a lighthouse emits a beam of light. How far does this beam of light travel in 1 nanosecond? So first of all, we call nanosecond is just 1 times 10 to the minus 9 seconds, and let's convert the speed that we're given here in natural units, in SI units, I mean. So this is 3.0 times 10 to the, so 1 kilometer is 1,000 meters, so 10 to the 3, so that's 10 to the 8 meters per second. So what is the distance traveled? Well, the distance is going to be the velocity times time, so it's going to be 3 times 10 to the 8 times 10 to the minus 9, which is just 3 times 10 to the minus 1 meters. So 0.3 meters is our answer. Let's now move on to the second part. Okay, so now in this part, we're told that the propagation time t is the time for a pulse to travel directly along an optical fiber, okay? A straight optical fiber, we're told now, has a length of 9 kilometers. Let's say this is 9,000 meters, and its refractive index is 1.5. Recall that refractive index from the first part was the ratio of the speed of light and the velocity of the light in that medium. Okay, so we need to find the time t, the propagation time t for this thing. Let's go ahead and do that. To do that, we need to find the velocity of light, which is going to be c over 1.5, which is 3 times 10 to the 8 from the previous part over 1.5, which is 2 times 10 to the 8 meters per second. So what's the propagation time? So the time is going to be the distance divided by the speed. So it's going to be 9,000 divided by 2 times 10 to the 8th. So let's cut this out. Divide by 3 here. This cuts, and this one gives 5. So we have 4.5 times 10 to the minus 5 seconds. Okay, so this is 4.45 times 10 to the minus 4 seconds. Sorry, I meant to the minus 6 seconds. Sorry, to the minus 6 seconds. So therefore, our answer is 45 picoseconds. So our answer is F. Okay, so now we're told that an engineer has used a refractive index of n equals 1.5 to estimate the nominal propagation time, T-num, for an optical fiber. The actual refractive index of the fiber depends on the wavelength of the light. For red and blue light, the refractive indices obey this inequality. So the refractive index of red is less than the refractive index of blue, and it's less than 1.5. Okay, we're told that T red and T blue are the propagation times for red and blue light, respectively. And now we need to compare which of the nominal times is correct. Okay, so let's see. Let the length of the fiber be L. Okay, so let's rewrite this inequality now in terms of velocity. This is just c over the velocity of red light is less than c over the velocity of blue light, which is just less than c over the velocity of just light in that medium, white light in that medium. Okay, so this tells us that 1 over VR is VR is the velocity of red light, 1 over VB less than 1 over VL. Okay, so let's compare those two inequalities now. So we know that 1 over VR is less than 1 over VB. What does this tell us about VB and VR? Well, this tells us that VB is less than VR. Therefore, we know one inequality now in terms of those two. So let's now compare those two here. Now we know 1 over VB is less than 1 over VL. Therefore, we know that VL is less than VB. Okay, crisscross multiplying here. Okay, so what is the ordering of the velocities now? Okay, so VB is less than VR, and VL is less than VB. So VL is less than VB, and VB is less than VR. So the ordering for the velocities is this. Okay, so now what is the propagation time now? propagation time, t, is given by the distance d divided by the velocities. So therefore, the propagation time, so t, is proportional to 1 over v. So we could either work out the inequality from using this here, or we could simply realize that it's the same inequality as here, because 1 over v is proportional to the refractive index. Therefore, the inequality is going to be in the same ratio as the refractive indices. So we're going to have T red less than T blue less than T nominal. Okay, so which one is this? So red less than blue less than T nominal. So the answer is A.